at the end of yesterday. So we got ourselves a polynomial equation that we're gonna have to write and then solve. And it says in this figure over here, the small cube is 1/4 the length of the larger cube. If the volume of the if the volume of the figure is 1,701 cubic centimeters, what are the dimensions of the cubes? So this right here, by the way, it's kind of an annoying question. It doesn't really specify that the volume of the figure is not the volume of the big cube. The volume of the figure does not include that. So it's like a cube, but it's notched out as well. So that is like gone from it. So it's mostly a cube, but like the corner is cut out essentially, which it's not very clear about. But the fact that we're subtracting them here indicates that that's what needs to happen. So I wish they were a little more precise in the wording on that, but we got to figure it out. So in terms of actually figuring out the volume of this thing, well, volume of a cube is length times width times height. So if you take the volume of the entire thing and you subtract that smaller cube away from it, that'll give you the figure, which is everything but that small cube. So 4x times 4x times 4x, length times width times height, would be the volume of the whole thing if you included this cube here. But then you're going to take away that cube from it, and the total volume is 1,701. So what happens if you cube 4x? What do you get? You might need a calculator today. I'm sorry, if you don't have one yet, feel free to go grab one. Okay. So 4x cubed, that means the power of 3 applies to the 4 and the x. It's already applied to the x here. So what's 4 to the third power? 64. Good. So 64x cubed minus x cubed, those are like terms. So what is 64x? Yeah, 63x cubed. Good. And so if we want to isolate our variable here, we would just do what? Exactly. It says it right there. Divide each side by 63. What is 1,701 divided by 63? 27. So x cubed equals 27. Gosh. I'm hesitant to show you how they're doing this here because, I mean, looking at this right here, I can just tell you what the answer is. Because we don't actually have to do that on this problem. I'll show you what they did here, and then I'll show you the faster way to do this. How about that? So if you're going to solve a polynomial equation, it's good to get it equal to 0. So you get it equal to 0 by subtracting 27 from both sides. And you get x cubed minus 27 equals 0. And then we've got two terms here. So based on what we did yesterday, if we look at our table at the beginning of the lesson, first look for greatest common factor between the two terms. Is there a GCF between x cubed and 27? No. All right. Then we look at number of terms right here. There are two terms in this particular polynomial. So two terms, we can be dealing with a difference of two squares, a sum of two cubes, or a difference of two cubes. So we're not dealing with a sum here, so that one's out. So it's either a difference of two squares or a difference of two cubes. Now, that is a third power there. So the implication is that it's probably going to be a difference of two cubes. Is 27 a perfect cube? Of what? 3, yeah. And I mentioned this yesterday briefly, but just real quick, if you want to see if a number is a perfect cube or not, just hit the button that says math. Scroll down to option number 4. That is the cube root button. So option number 4 to the cube root, hit enter, and then you can just type the number underneath it. If you get a whole number underneath from a cube root, that means that the number is a perfect cube. So 3. So we're going to use the difference of two cubes factoring property here. So cube root each of them, which in our case would be A would be equal to X and B would be equal to 3. So we're going to get X minus 3 in the first set of parentheses, which is right here. And then we're going to end up with X squared plus A times B, which would be 3X, plus B squared, which would be 3 times 3, which is 9. And then in order to solve this, you would set each of those equal to 0 and get the results from that. Now, if you set this equal to 0 and solve for X, what do you get? 3. Okay. Now, if you set this one equal to 0 and you solve for X, that is not factorable, which means you'd have to use the quadratic formula. So what I'm going to do is just highlight that there, and then we'll move it over here. And we'll use the quadratic formula. And so we just got done with the quadratic formula, I think a couple of units ago. So we're going to say X is equal to the opposite of B plus or minus the square root of B squared minus 4AC, and that all divides by 2 times A. So we're going to use that to solve. What's our value of B then in this particular quadratic? I'll just write it up here as well. X squared plus 3X plus 9 equals 0. So what's our B value here? 3. B is 3. A is 1. So we're just going to write A equals 1, B equals 3, C equals 9. So that's value of A, B, and C. A is always the number with the squared variable. B is always the number with X. C is always the number by itself. Don't ever include X in your A, B, and C. It's only the coefficient values for those. All right. So we're going to get X is equal to the opposite of B, so negative 3 plus or minus the square root of, here we go, 3 squared minus 4 times A is 1 times C, which is 9, all divided by 2 times A would be 2 times 1, so 2. Just go right to. All right. 3 squared is 9. 4 times 1 times 9 is 36. 9 minus 36 is what? Negative 27, right? Yeah. So X is going to equal negative 3 plus or minus the square root of negative 27 over 2. It's actually going to be some good review. What happens if you have a negative under a square root? What's that? Yeah, we're going to get I. The imaginary unit will be part of this. So that's going to end up equaling negative 3 plus or minus. There is a perfect square factor of 27, which is 9. What's the square root of 9? 3. So this is going to be plus or minus 3i. And if you divide out a 9 from 27, what's left? 3. So that'd be plus or minus 3i root 3 over 2. Which is why this answer ends up being what it is over here. Same thing. Now, since 3, go ahead and write this down. Since 3 is the only real solution, the lengths of the cubes are... The small cube has lengths of what? Look at the diagram. Yeah, 3 centimeters. And then the large cube would be what? 12, yeah, because you're multiplying it by 4. 3 times 4 is 12. So 12 centimeters to the lengths of the large cube. Now, it wasn't entirely necessary to go past this step right here. And the reason for that is x cubed is equal to 27, which means the number that multiplies by itself 3 times to equal 27 is the answer to this problem. What number multiplies by itself 3 times to equal 27? 3. So at this point, honestly, we could have just cube rooted both sides here, because the cube root of, just going to go ahead and over here with this one. X cubed equals 27. If you cube root each of these, x equals 3. So factoring wasn't entirely necessary there, but it was a good review in order to factor that, just to do the review of it. But I would not have used factoring to solve that. I just would have looked at that and said, oh, I know that 27 is the perfect cube of 3, so the answer is 3. And it would take less time. And that is the only real answer. There were other answers, but the other answers weren't real answers. We had 2 complex answers because we had I involved, but those don't actually make sense with this problem. So, all right. That's for solving using those identities in order to factor. So now some polynomials, it says right here, some polynomials in X can be written in quadratic form. This is an odd concept, the way it's written. I'll explain what this is talking about. Actually, just using these ones over here. So it says an expression in quadratic form can be written as a times u squared plus b times u plus c, which is the standard form of a quadratic function or quadratic expression. It just doesn't use x, it uses u instead, which is a little bit weird. For any numbers a, b, and c, where a is not equal to 0, okay, u is some expression in x. Basically, what happened is something that had x was then substituted out and replaced with u. That's what's happening here. And I'll show you over with these ones in just a second. The expression au squared plus bu plus c is called the quadratic form of the original expression. For example, this is not a quadratic. Why not? What is the maximum exponent if something is a quadratic? 2. Yeah, that maximum exponent is 10. This is not a quadratic. However, it can be written as a quadratic because if you think about what squared means multiplied by itself, right? So you could technically multiply something by itself in order to get x to the 10th power. What multiplies by itself to equal x to the 10th power? X to the 5th power. X to the 5th power multiplied by itself equals x to the 10th power. So this could be written as 2u squared plus u plus 9. Because in this case, what does u equal for this particular expression? What did we replace u with? Or what was replacing? What did you replace? That's a better way to ask that. What did you replace? X to the 5th power. Yeah. So you could write this as, you could write this. We're going to say u is equal to x to the power of 5. Because if you think about what that means, this would be 2 times x to the 5th power squared plus x to the 5th power plus 9. You're basically creating a quadratic out of something that could be rewritten as a quadratic. So like on this one here, what would we say? What can we do with this one? Any thoughts on that? What's that? Yeah, the x to the 3rd power would definitely be part of u. Now it's possible that it could be more than that. But we'll see what happens on the next page because we definitely need some more work. So let's turn the page and let's do some practice on these. This will kind of show us in a little bit more detail what we're doing as well. So This problem here says 4a to the power of 20 plus 6x to the power of 10 plus 15. Examine the terms with the variables to choose the expression equal to u. Now, if you think about what we've got going on here, now we know that x to the 20th, or hopefully we should know that x to the 20th is x to the 10th times x to the 10th. Because if it's x to the 10th times x to the 10th, you'd add the exponents. 10 plus 10 is 20, which would be x to the 10th power squared. Now, u is not just x to the 10th power here. It shows you right here that u is actually 2x to the 10th power. Because we're actually trying to get, as best as we can, if that first term can be a perfect square, then we want to write that as a perfect square. And since 4 is a perfect square, it's the perfect square of 2, you could write this as 2x to the 10th power. Which means that you'd also have to divide out a 2 from this 6 right here in order to get the number that's on the outside of it. So for example, this is going to be 2x to the 10th power squared, because 2 times 2 is 4, and x to the 10th squared is 20. So we can write that as a quadratic. Now the middle term, think about this for a second. 2x to the 10th power is our value of u. Basically what we're writing here is u squared plus something times u plus something else. Now that something else should just be 15, because that's what was at the end of it. So go ahead and you can write that 15. Feel free to do that. Because the 15 doesn't ever take part in the process of what u is equal to. U is always replacing something with x. And since this last term doesn't have something with x, we don't need to mess around with it. But what number multiplies by 2 in order to equal 6? 3. So we're actually looking at u squared plus 3u plus 15. Because the value of u has to match in both the first term and the second term. So that's what we've got going on with that one. So you can rewrite that as a quadratic. And then once you have it written as a quadratic, you can solve, which we will do on example 7. But let's practice this a couple more times here. Now, if your polynomial is not written in standard form, write it in standard form. So standard form just means greatest to least in terms of the exponent. So you just got to swap these first two terms. So we got 180, sorry, x to the 8th power plus 18x to the 4th minus 28. Now, this is where it gets a little bit more challenging, because 180 is not a perfect square, is it? No, all right. However, it appears that there is a perfect square factor. And this is where we start having to think about, like, this number here, 180, you have to start thinking about it sort of as like the square root of 180. Because you're trying to figure out, is there a perfect square factor of that number? So if you think about how, think about 180, just start, see if it divides by certain values. Now, I'm pretty sure that would divide by 9. 9's a perfect square. 180 divided by 9, that works. It's 20. What about 16? No, not times, sorry, 180 divided by 16. No, that doesn't work. How about 25? No, that doesn't work. How about 36? Yeah, that does work. And then 5 is what's left over. So 5 is not a perfect square, and it can't be reduced from a perfect square. So 36 is the largest perfect square factor of 180. So you could write the square root of 180 as the square root of 36 times the square root of 5, which equals 6 root 5. And so what ends up happening is we're not actually dealing exactly with square roots here, but we are kind of thinking in that pattern because we want to be able to square root the largest perfect square factor of this number. And if you square root 36, you get 6, and you'll notice there's 6. And since x to the 8th power is equal to x to the 4th squared, you actually get 6x to the 4th squared. And if you divide out a 36 from 180, what's left over is 5. And so the 5 is what goes here. It's not under a square root because we're not, like I said, we're not actually simplifying a square root, but we're doing a similar process to simplifying a square root. Because if you think about how this works, if you multiply out 6 times 6, you get 36. And then if you multiply 6 times 5, you get back to 180. So it's just kind of condensing things down. And then if you expand it back out, it should just go right back to where it started. So in the middle here, if you divide out a 16x to the 4th from 18, what number is left out here? What's 18 divided by 6? 3. Minus the number 28. That regular number isn't never really going to change. All right. Now, C cannot be written as a quadratic. And that's because x to the 6th power, while it is a factor, sorry, not a factor, it is a multiple, 6 is a multiple of 2, it's not the square of x squared. X squared squared is x to the 4th power, not x to the 6th power. So this one actually can't be written as a quadratic. The term in the middle, the exponent in the middle, has to be able to be squared to equal the exponent at the front of this in order for this process to work in the first place. So the expression cannot is our word here, cannot be written in quadratic form. Take a look at this last one here. What's our first thing that we need to do with this problem here? Standard form, yeah. Because that 10x to the 4th is a smaller number than the exponent here, which is x to the 8th. So let's rewrite this as 100x to the power of 8 plus 10x to the power of 4 minus 9. Okay. Is x to the 8th power the square of x to the 4th power? Is x to the power of 8 the square of x to the power of 4? Yeah. Okay. Now, 100 by itself is a perfect square, isn't it? 100 is a perfect square of 10. So we could probably write this as it seems like we could just say 10x to the 4th squared right? Plus 10x to the 4th, right? That seems to be, because that middle term is not going to change. 10x to the 4th minus 9. Because if that's our u value, then our u value is there as well. Now, this isn't actually the only answer here. Kind of an interesting thing because, and actually this isn't the only answer for this previous one either. To write something as a quadratic doesn't mean there's only one way to do it. So you could actually get different answers for these. As long as you write it as a quadratic, you are correct. For example, this one here, just because the whole thing is a perfect square doesn't mean it's the only answer, because there is another perfect square factor of 100, which is 25, right? 25 is a factor of 100, and 25 is a perfect square, isn't it? Okay. So that means that if you factor out 25, you could say, or our value of u could be 5x to the fourth power squared. Because if you square this, you get 25x to the eighth power, which means you'd still have to multiply 25 by what to get it back to 100? 4, okay? And then you'd say plus, and then we'll do a little set of parentheses here. And then we'd have 5x to the fourth power here. What would you have to multiply 5x to the fourth power in order to make it equal 10x to the fourth power? 5 times what is 10? 2. So plus 2 times 5x to the fourth minus 9. Okay, that didn't fit in there very well. Minus 9. So that is another way you could write it, because it's still written as a quadratic. There's not just one way to do this. In fact, this problem up here, we saw that you could actually divide out a 9 from this one. If you divided out a 9 from this one, the square root of 9 is 3. So you could have 3x to the fourth squared. 3 times 3 is 9. And then 180 divided by 9 is 20. So that could be 20 times 3x to the fourth squared. Plus, and then you'd have 3x to the power of 4 in here. And in order to get back to 18, that 3 would have to multiply by 6 instead, and then minus 28 after that. So there's actually 2 legitimate answers for this one as well, not just one answer. So sometimes there is only one way to do it, but sometimes there's multiple ways to do it. As long as you can write it in a format that is a quadratic, then you're good. That's it. So let's try one more of these, and then let's actually do this to solve something now, because the whole idea here is to be able to solve a polynomial that is much larger than a quadratic, but solving it like you would solve a quadratic, which is great because we have excellent methods for solving quadratics. We have the quadratic formula, we've got factoring, we have all that other kind of stuff. And so if you can rewrite a function as a quadratic, it makes it a little bit more straightforward to solve. So here we go. 8x to the power of 4 plus 10x squared minus 12. This is not a quadratic. This is a quartic function. But because x to the fourth power is the same thing as x squared squared, it can be written as a quadratic. In fact, there is a perfect square factor of 8, which is 2. You can divide out, not 2, it's 4. The perfect square factor of 8 is 4, and the square root of 4 is 2. And so if you were to multiply out 2x squared squared, you get 4x to the power of 4, which means you'd still have to multiply it by 2 to make it equal 8. So 2 goes here. And since we're saying that our value of u is equal to 2x squared, that's essentially what we're doing here. And we'll talk about that in a second. We're going to do some substitution here in a moment. What do you have to multiply 2 by to get it back to 10? Bless you. 5. So we've got 2 times 2x squared squared plus 5 times 2x squared minus 12 equals 0. Now, if we rewrite this using u and we write it as a quadratic, whatever's in the parentheses is going to be your u value. So this will be 2 times u squared plus 5 times u minus 12 equals 0. So there's a u, there's a u, u, and u. So if we write this out as 2u squared plus 5u minus 12, we can then factor this, or at least try to factor it using the factoring process. If it doesn't factor, we could always use the quadratic formula. This one does factor though, so let's go over here and factor. Now we're gonna have to use the slip and slide process for factoring. So that means you're gonna multiply 2 times negative 12, and that'll give us u squared plus 5u. And then what's 2 times negative 12? Negative 24. All right, so minus 24 and then equals 0. So let's think about what 2 numbers would multiply to negative 24 and add to 5. What 2 numbers multiply to negative 24 and add to 5? Positive 8 and negative 3. Good. So we got u plus 8 times u minus 3 equals 0. Now, we're not quite done with the slip and slide method here because we multiplied the original a value to the end. So that means we need to take the original a value, which is 2, and those both need to be divided by that value of a. So these two numbers, the 8 and the negative 3, both have to be divided by 2. 8 divides by 2 evenly to equal 4, so that's going to be u plus 4. And then 3 doesn't divide by 2, so that means we need to slide the denominator back in front of the u here, so that'll be 2u minus 3, and that equals 0 there. So there's our factored form. And if you look back here, we've got the u plus 4 there already. So that means that this set of parentheses is going to be the 2u minus 3. So 2u minus 3. So then we solve for u. So we set these sets of parentheses equal to 0 and then solve for the variable. So 2u minus 3 equals 0. Add 3 to both sides. 2u equals 3. Divide by 2, which means that u is equal to 3/2. So that's one of the values of u. The other value of u is just going to be negative 4, because if you set that equal to 0 and solve for the variable, you get negative 4. So we've solved our quadratic. However, it wasn't a quadratic initially. It was a quartic, right? So once you have your variable, once you have your u variable solved for, then you can substitute back in what the u value actually is, which is 2x squared. So we're going to swap out u back for what it actually equals, which is 2x squared. And then we solve for x. So on the left side, you divide by 2 to get the x squared by itself. So 3/2 divided by 2. Anytime you divide a fraction by 2, just double the denominator. So 3/4. X squared is equal to 3/4. From there, you'd square root both sides. So if you square root here and you square root here, the square root of x squared is x. And the square root of 3/4 is going to be plus or minus root 3 over 2. The square root of 3 doesn't simplify, but the square root of 4 on the denominator just equals 2. So plus or minus root 3 over 2. That's 2 of the possibilities. Over here, divide both sides by 2. X squared equals negative 2. If you square root a negative, you have to use the imaginary unit. So we end up with plus or minus I root 2. Which means we have two real answers, root 3 over 2 and negative root 3 over 2. And we have two complex numbers, two imaginary numbers, I root 2 and negative I root 2. So my question for you is, how many times does this cross the x-axis? Twice, yeah. How come? Why is it only twice when we have 4 answers? Yeah, the two imaginary ones, those don't actually show up as x-intercepts. These ones will. In fact, let's graph it. Let's prove what we've just seen. So we're going to have 8x to the 4th power plus 10x squared minus 12. And then graph it. There are the x-intercepts. We can see them. And let's go ahead and just type them in and see what we get. So calculate 0. This is what we did on Tuesday, right? Figure out where our x-intercepts are. So to the left, to the right, enter again. And that is negative 0.866. Well, it'd probably be worth it to find out if negative root 3 over 2 is equal to about negative 0.866. So let's go and say math fraction negative square root of 3 divided by 2. Look at that, negative 0.866. It works. Nice. So if we head back to our graph, we can figure out the other one. hopefully it's positive about 0.866. So root 3 over 2. So calculate, figure out the 0. Let's go to the right a little bit and enter and enter and enter one more time. Hey, look at that, 0.866, which is the positive version of it. So everything that we did on Tuesday is still what we're doing now. We're just using the algebra version of it as opposed to the graphing version of it. All right. Let's do the last one, and then you will have the remainder of class, which should be around 20 minutes of work time. So actually, no, more than that, because we're not out of here at 42 today. We're out of here at 49 today because we're on an advisory schedule. So yeah, you're gonna have good work time today. All right. Is this in standard form? Yes. Okay. This is in standard form already. Great. So let's head over here and let's see. Is x to the 4th power equal to x squared squared? Yes. Okay. So we can write this as a quadratic. Is 16 a perfect square? Yes. Okay. So that means we could write this as, I'm going to give myself plenty of room over here. We could write this as 4x squared squared, because 4 times 4 is 16, and x squared squared is x to the 4th, which means we're going to write plus, and then we're going to have 4x squared in parentheses here, and then we just need to figure out what number goes outside. 4 times what equals 24? 6, yep. So plus 6 times 4x squared minus 40 equals 0. What is our value of u then? Okay. 4x squared, yeah. So we're going to say u equals 4x squared. Now we're going to write the quadratic version of this because it didn't start off as a quadratic, it started off as a quartic. So we're going to have u squared plus 6u minus 40 equals 0. Now, the nice thing about this one is because the first term is a perfect square, we don't have to use slip and slide on this one. We just have to figure out 2 numbers that multiply to negative 40 and the same 2 numbers that add to 6. Multiply to 40 and add negative 40 and add to 6. Switch through the negative is, but yeah, 10 and negative 4. So 10 times negative 4 is negative 40. 10 plus negative 4 is 6. So we've got u plus 10 times u minus 4 equals 0. Which means that u equals negative 10 and u equals 4. If you set them equal to 0 and solve for u, you get those. Now we're going to swap back in the thing that u actually equals, which is 4x squared. So we're going to have 4x squared equals negative 10, and we'll have 4x squared equals 4. And then we can divide by 4 over here, which would be negative 10 fourths, which would be negative 5 halves. So x squared equals negative 5 halves. And then over here, x squared equals 1. 4 divided by 4 is 1. And then if we square root both sides, well, that's going to be x is equal to plus or minus I square root, no, the I times 2 root 5, no, 5 root 5. Hang on. Nope. Plus or minus root. Oh my gosh. Hang on. I'll just write this over here. So x squared equals Negative 5 over 2. This one, by the way, is just positive and negative 1, because if you square root 1, you get 1 and negative 1. So the real answers are going to be 1 and negative 1. However, the imaginary answers are going to be a little bit different. So I'll just show the work for this one. So you're going to factor it out. So you're going to get x is equal to plus or minus I times the square root of 5 divided by the square root of 2. But then you have to rationalize the denominator by multiplying the numerator and denominator by the square root of 2. So it's going to be root 10 over 2 is what I was trying to write earlier. Multiply by root 2 over root 2. So then x will equal plus or minus I root 10 over 2. So we're going to have negative 1. We're going to have 1. We're going to have I root 10 over 2. And we're going to have negative I root 10 over 2. So once again, we have two real intercepts on the x-axis. One at negative 1, one at positive. All right. That's it for lesson 5.2. Tomorrow's lesson is short and much less complicated than the one that we just did over the last 2 days. And tomorrow is lesson 5.3, which means we only have 2 more lessons to go through in this unit for next week. So that test will be coming up pretty quick, actually. So 1 through 67, every other odd. That is your assignment.